I'm Allison Meyer. Thank you for joining us for this month's MEYERTech webinar. We will be continuing this webinar series every other month to share insights into the many ways Meyer is using tech to troubleshoot, solve problems, and develop solutions in our industry. To start, I'd like to take a minute to tell you a bit about Meyer in case you're not already familiar. Meyer engineers and manufactures rugged, reliable, smart products for drilling well control systems and well testing equipment. We are API 16D licensed and headquartered in the United States with international reach. This month's featured speakers are Ron Marsden and Zach Chapman with Manta Robotics. Manta provides refineries and tank farmer owners a safe and efficient, non-destructive testing inspection for large hydrocarbon storage tanks. This groundbreaking technology uses ultrasonic technology to inspect the floor, including the critical zone, which provides an accurate tank floor plate condition assessment with limited or no downtime. Feel free to send questions to Ron and Zach during their presentation using the chat function here, and we will do a short question and answer session after they present, and I promise we will be very respectful of your time. Over to y'all.
Okay, so as was mentioned, my name is Zach Chapman. Go ahead and introduce Manta Robotics here. To begin with, we are an in-service tank inspection company that specializes in the construction of ROVs for use in potentially hazardous environments as far as ASTs, above ground storage tanks go. We're based out of Eastern Idaho Falls area. We've been active in the industry since 2016 with over 50 tanks inspected. Over the next few slides, we're going to be going over certifications, the design of our ROVs, how we've met explosion-proof designs. We're going to discuss some of our first ROVs to market, including in-depth discussion on our Class 1 Group D certifications that we were able to achieve. Ron will be going over the 3 robotic systems that right now we do have in our toolbox, as well as covering some of the technology that's involved with the ROVs. So we start with the next slide. Next slide, Ron's going to go ahead and talk about certification, some of the technology, and then even how we collect UT data and visual data as well.
First off, real excited to be here. Thanks, Myers, for allowing Manta Robotics to participate. With the design of the ROVs, we felt it was very important to take into consideration the safety aspect of these ROVs. And so in our original concepts, we started out with how are we going to get the ROVs certified so that they were a Class 1, Div 1, Group D certification. Our main emphasis was to incorporate into our design the aspect of meeting the requirements necessary to achieve that Class 1 Div 1 Group D. We did go through a third party known as MEYERTech. MEYERTech Testing Services is the 3rd largest testing center in the actual world. And in our design, we actually went through and we focused on doing domestic certification and also European certification. So we wanted to meet the NEC, the NFPA, and the IECEX certifications. In doing that, it took several years and a lot of resources, including a capital, to go through this certification. The secret that, well, I shouldn't say secret, but the process that we used in our designs is known as a purge and pressurized system for obtaining this certification. And what that means is that we actually have a system that's purged and pressurized using nitrogen. And in this pressurized system, we have alarms and indicators that if we drop any pressure, the system automatically shuts down. And so that meets the safety requirements, and that gets us into that Class 1 Div 1 Group D certification. And as mentioned, it took several years and a lot of capital to obtain this. And so our focus was on the safety aspect and meeting that so that we had a niche in the market. And our ROVs do meet all these certifications, and we're able to meet and exceed the API 653 standards for going through and inspecting the ASTs. Next slide. Okay, we started out, our original concept was known as a crawler. This is our original design for the ROV. On this crawler, we actually have 8 ultrasonic transducers that are on this system. We have a rotisserie brush on the front of it to move debris and sludge and particles out of the way so that we can have a clean slate for the transducers to take measurements on the bottom of the plate. Included in this ROV design was 2 cameras. We have an infrared camera and we have a high definition white light camera where we can do visual as well as taking the measurements with our transducers. This complete unit weighs over 150 pounds, and so we use a gantry system to lower it down into the tank through the manway. The minimum manway that's required for this system is 20 inches. And that allows us to get through the manway, and then we're able to lower it through a gantry system to the bottom of the tank. And on this system, we have an umbilical cord. The umbilical cord is what houses all our communications and our nitrogen system. And we have that umbilical cord go to a command center that's outside the berm of the tank. We also have a sonar system, which I'll get in depth a little bit in that technology, but we have a sonar system on this ROV so we can position real time our location as we're taking the UT data. On this system, we're able to take hundreds of thousands of points throughout the entire bottom of the tank. And we're able to do that real time and capture that data and our position real time. And this system was and is a Class 1 Div 1 Group Group D certification through MEYERTech. And we do certify to the NEC, NFPA, and the ICX certifications. Next slide. From our experience on our first generation system, we realized that there was a lot of infrastructure inside the tanks and areas where there were areas that we could not get to measure with that crawler. And so we started developing and started thinking of a way of getting around that and being able to obtain data around the infrastructure and in areas where we had difficulty with the crawler. And so we came up with another ROV, and we refer to it as a swimmer. The swimmer allows to go up and around and swim over infrastructure or obstructions. This system actually houses a single UT probe. It's a contact probe, and we take individual measurements with that UT probe. And as mentioned, we were able to maneuver around obstructions, infrastructure, things of that sort. It also has 2 cameras. It has an infrared camera and it has a high definition white light camera that we're able to tilt and maneuver. This system is a lot more user friendly. It weighs less than 20 pounds. We're able to lower it in the manway to the bottom with just a single person. The minimum manway condition needs to be 18 inches or larger. We also have sonar on this system as well. And as mentioned, I'll get into the sonar technology. But we've also taken this system and have been able to get it certified using MEYERTech services. And it is also a Class 1 Div 1 Group D certification, which allows us to get into hazardous environments. And we have met all the guidelines for those certifications for this system. And this is the system that is really our bread and butter, our powerhouse. We use this system more than any of the other systems in our toolbox. But this system has been heavily used, and it's our next generation or our second generation system that we've got in our toolbox. Next slide. Okay, our third system, we've come up with this system due to requirements for smaller tanks. We wanted to have something that was able to be transported via FedEx or UPS, something that we could ship out to a client and then fly out and do our inspection for the bottom of the tank. This system we refer to as our probe or our pole system, and it's got actually the pole itself with the shoe, with the UT and the sonar. The pole itself weighs less than 10 pounds, but the entire system with the sonar and our computers and things of that sort weighs less than 100 pounds, and we're able to ship that to the client site and then show up on the client site and do the inspection. It's a carbon fiber design. It does have a high definition camera and infrared camera. It also has a UT probe on it, and we take individual measurements throughout the tank. And the minimum man weight for this particular system requires 8 inches or more, and it does have the sonar capability, so that sonar allows us to see where we are real time. Next slide. Okay, this slide here on our is talking about our sonar positioning. Sonar allows us to, with this sonar system, we're able to put beacons on the outside of the tank, and we position a minimum of 4 beacons on the outside, strategically placed around the circumference of the tank. We have a pinger that's actually located on the ROV. And so between the beacons and the pinger, there's a communication that occurs, and it's a sonar communication, and it identifies the actual location of the position of the ROV or the probe that's inside the tank. And we're able to position ourselves and see it real time. And we also take a drawing that's been given by the owner or the customer of the tank, and we're able to take that bottom drawing of the tank and overlay it on our sonar map so that we can see know where the obstructions are, know where the infrastructure is, know where things are at, and also see where we are real time when we're taking our measurements. And so this technology allows us to see where we're at, see where the obstructions are, stay away from the obstructions because we don't want to jeopardize the integrity of our equipment, but take enough data that meets or exceeds the API 653 requirements. This is a great technology. There's things that we're doing to develop it, to refine it and enhance it. But this is a great tool to have to see where you're at real time, where you're taking your measurements. Next slide, please. Okay, along with the UT and the sonar technology, we have a command center, as I've mentioned, with our 2 ROVs that have umbilical cords. The communication center or the command center is outside the berm area. And this is where the operators of the ROVs are stationed, and they're able to see where the ROV is, and they can see the actual measurements that are taking place real time, so they can actually see the actual condition of the tank and be able to visualize where things are and take the measurements and see where they're at and map it real time. And so this is basically a utility trailer that houses an office with the equipment inside of it, away from the tank, outside the berm area, that's allows us to be away from the tank while we're doing our inspection. And this is, like I said, it's really an office inside of a trailer. And we have this technology that we're able to control and to run and to maneuver right from this position to allow us to do the inspection. Next slide.
Okay.
I think it's moved over. It's just an internet connection.
Oh, okay. Okay, so I can take it from here. So the project that we kind of wanted to bring up and show that there's other applications other than just fuel oil, petroleum tanks. We actually had the opportunity to work with the DOE. It was first in DOE history as far as developing a camera fixture for internal visual inspections. We were able to come up with a system that eliminated the need for confined space entry, able to collect sufficient visual data within the tanks and the liners of extremely corrosive acid, that'd be the hydrofluoric acid. Again, we were able to eliminate the need for confined space, which was huge, especially being how corrosive this material is to humans. But the point of this slide is to kind of just let everyone know that if there is a tank that kind of has a unique solution that needs to be developed, that we can put our heads together and really try to come up with an application that can help the tank owner with those tanks. We can go ahead and move to the next slide. Again, applications, right out of the gate, our biggest applications for this within the industries is refined petroleum products, as far as, fuel oils, diesel, light fuel oils, even oil-based motor oil products. Where we kind of get into where each tank needs to be a case by case, where we need to analyze and really research each tank before we put a ROV in the asset, is when it comes to unrefined petroleum products such as crude oil, or even if the tank has been in service for a while, there's known sediment, there's known sludge. These are all factors that really need to be taken into play before diving in with an ROV to perform the inspection. That doesn't mean that we can't do it, and same with acid solutions. Depending on what the acid solution is, we may be able to get an ROV into that tank to do the inspection. Again, it's a case by case per tank. So, if you do have any questions on if this is a candidate for your tank, feel free to reach out and we can analyze the tank, analyze the contents, determine if there's any sediment, sludge, and kind of develop a game plan from there. We can go ahead and move to the next slide. Again, applications, we've had the opportunity to work in almost all industries applying this technology. As far as power generation facilities, it's been really popular. Backup diesel storage tanks, remote areas where they don't have the capacity to store fuel or transport it. That's really when you start seeing the big cost savings, is when the tank owners are like, where are we going to put this fuel? Where are we going to store it while we're performing an out of service inspection? So again, it's applicable to all tanks. It's just a case by case when it comes to the tank and its contents. We can go ahead and move to the next slide. Benefits. I want to spend some time on this slide. Right off the gate, the biggest one, the primary reason why we developed this technology was to eliminate the need for confined space entry. So no confined space entry. We're also eliminating the need for hot work or limiting it. As far as the release of VOCs into the atmosphere that are incurred during an out of service inspection, we help reduce and almost eliminate the need for that. Traditional out of service inspections, they currently require the AST to be drained of their contents, cleaned, and degassed prior to entry. So this process creates unwanted release of VOCs into the atmosphere and can present serious environmental challenges. So by utilizing robotics, operators can eliminate the need for degassing, as well as requirements to collect emissions and to properly dispose of the AST waste materials. So another big thing, reduced project planning. We take an out of service inspection that an operator can incur weeks or months of downtime, and we reduce that. A typical in-service robotic inspection on a 100-foot diameter tank, we're going to have that tank done in a week, less than a week in some cases, depending on the infrastructure within the tank as well as the contents or if there is any sediment or sludge present. So by utilizing the robotics, there will be no need for the tank to be taken out of service for the inspection. This helps eliminate scheduling difficulties. And the big thing is it helps limit the amount of contractors that the operator, the tank owner, is going to have to hire out to perform all the functions that are required to perform an out of service inspection. Crew size, we can operate our swimmer ROV with 3 to 4 personnel. So 3 to 4 crew members on site for a week. And we really have limited how many contractors are going to be present. Same with our crawler system. It requires an additional crew member. That's just because of the weight and staging and just an extra hand on site to help move that around. As far as our probe system, it's operated 1 to 2 people. Like Ron was saying, it can be shipped directly to the job site. This application has worked really well for remote areas. We've contracted some jobs up in Alaska, different remote areas where we can actually fly the equipment in to perform the inspection. So we can go ahead and move to the next slide. Questions. So does anyone have any questions?
It doesn't look like any have come in. What are some typical questions that y'all generally get from people interested in your service that you could answer?
A big one would be limitations. And we did kind of cover some of the limitations as far as sediment and sludge go. But that would probably be the big one. That's why we take every tank case by case, because there's a lot of different scenarios that you can come up with as far as where that tank sits within the plant, how are we going to access it, what equipment's required to stage it. And typically to stage our equipment, we're renting or acquire a boom lift on site to where we can stage personnel, stage the ROV to the tank top. So that would be a big one, limitations of the ROV, which there are, but most of the time they can be worked through.
Another question that's brought to our attention often is that they question the operator, the owner, or people with a tank question whether they can still be in operations during the time that we have that we're there to inspect. And the answer is yes, absolutely. It does not affect operations. You can stay in operations. You do not need to do anything with the tank. You don't need to shut it down. You don't need to drain it. You don't need to do anything with that tank. You can stay in operations. Your facility can stay in operations. We work with the group or the facility. We take any type of safety courses that they may require. We'll do that on site. Safety is a big deal. We have a tailgate meeting at the beginning, at the end of the day. Safety is a huge thing, but the operations of that facility can stay and be maintained during the time that we are inspecting the tank.
Mm-hmm.
Any other questions?
Perfect.
And Zach mentioned, we do tanks on a case-by-case basis, depending on the content, the size, the location, the infrastructure. And the reason why we do this on a case-by-case basis is because we don't want to jeopardize the integrity of the equipment or of our personnel. And so we take each tank individually to make sure that it is a good candidate. And there's times when we say, no, it's not. There's times when the tank either has had issues with it in the past with previous inspections. We are not going to go and do a tank that we know would have an issue or failed. If we know that it needs to be drained, we'll be upfront with the customer, with the owner, or with the person involved with that tank. We don't want to just go and do a tank just to do it. If we know it needs to be reworked or going to have issues with it, we'll tell them, hey, we're not a good candidate. It needs to be done the traditional fashion so that it can be reworked or have things done to placed or things of that sort. So We really are a company that believes in integrity. We're not going out just to make money and doing the inspection. If we feel that there's a tank that is not good for this application, we'll be upfront, and we have turned down several jobs due to it not being safe for us or our personnel, or to jeopardize the integrity of our equipment.
We have a question come through here. What is
We just received one question.
is the number one driver behind tank owners' decisions to use Manta? So I would say the number one driver behind tank owners using Manta would be the sheer fact that there's no downtime incurred over the course of the inspection. That tank can remain completely in service throughout the inspection, so there's literally no downtime incurred by the operator. We're there, we're done within a week. You haven't lost any, production of that tank. It's right back into making money.
Yep. And then safety, and then environmental impacts.
Yep.
Thank you so much, Ron and Zach. That looks like all the questions we have for today. And in closing, I would like to thank everybody for spending this time with us today. If you have any questions about Manta Technologies or Meyer, please feel free to call or email me anytime at 877-44 or marketing@meyernow.com. If it's relating to Manta, we will definitely reach out to Ron and Zach and have them answer any questions we are unable to. And we'd love for you to join us for our webinar on Wednesday, April 10th, featuring MEYERTech, the Internet of Things. Thank you today. We hope to see you soon.
Thanks, guys.